Question 5, you're supposed to find the foot of perpendicular from a given point A to the plane. So you look like this, on the diagram look like this. So we have a plane pi with a normal vector n, and you're given a point A, and you're supposed to find the foot of perpendicular from A to the plane. So you're supposed to drop 90 degrees down to the plane. And if you call this point P, then vector AP should be parallel to N. So which means if you find equation of the line AP, you can just take N as the direction vector of the line. So for part 1, right, you can convert this equation to R dot 3 minus 4, 1 equal to 5. So you can take the direction vector of the line AP to be parallel to 3 minus 4, 1. As for the second equation, you can write it as R dot with 3, 0 minus 4 equal to minus 9. So you take null vector as 3, 0 minus 4. Let's get a solution to part 1. So first, you're supposed to find foot of perpendicular. So you try to find equation of the line AP, and then you find the intersection point P. So the line passing through A perpendicular to the plane 3x minus 4y plus z equal to 5 will have direction vector 3i minus 4j plus k, right? And passing through 5 minus 3, 4. So it means this is the equation of the line AP I mentioned here, AP. Then after that, you sub the equation of the line to the equation of the plane to find the position vector of P. So you sub it in and work out the dot product. Will give you 31 plus 26 lambda equal to 5. So lambda is minus 1. With that, you can find the intersection point, and the intersection point will be the foot of perpendicular from the point 5 minus 3, 4 to the plane. And it will give you 2i plus j plus 3k as the position vector of the foot of perpendicular. So the intersection point is 2, 1, 3. So that means the foot of perpendicular from A to the plane is 2, 1, 3. So that means if A is a point 5 minus 3, 4, then this will be the foot of perpendicular, which is the answer 2, 1, 3. So this point will be 2, 1, 3. You are supposed to calculate the distance from A to pi. So it means you have to find the length of vector AP. And if you look at what you have, right, O is the origin. OA plus AP will give you the vector OP. So which means if you look at this part, if you look at vector AP, is actually the lambda 3 minus 4, 1 in the equation. So which means to find the length of AP, you find the length of the vector lambda magnitude of 3 minus 4, 1. So that's why you find magnitude of lambda 3i minus 4j plus k, which is same as magnitude of lambda magnitude of 3i minus 4j plus k. Magnitude of 3i minus 4j plus k is just square root of 3 square plus minus 4 square plus 1 square. You give us square root of 26. Lambda is minus 1, right? Magnitude of minus 1 is 1. So which means the answer is just square root of 26. The working for part 2 is same as part 1. It's just that you have a different point and an equation of a different plane.